Hello, everybody. So the lighting talk today will be on render targets. So yeah, the first thing that we need to clarify is that just render targets are not just a concept for like a thing that we use in Unreal Engine. So what are render targets? Render targets are something that you put in a 3D interactive environment, and you can draw on this specific thing. Like it's kind of like a canvas in the 3D that you can draw on, and then use it. So Microsoft definition for that is like literally they write it like that. Like render target simply is a location that you can draw on in an interactive 3D world. Okay. So what we're going to talk about today is like what are the render targets inside Unreal Engine. So this talk specifically will be inside render targets inside Unreal Engine and how they handle this, and what actually render targets did solve for us. So and some examples of how we can use it, and there are a lot of interesting ones, and like some known limitation to keep in mind while working with them. So to start off, so what is the problem that that may introduce like that may be the biggest use for the render targets? So one of the most interesting thing that we can use render targets on is drawing a thing on real time or modifying an object real time inside a specific material. So to modify an object or to modify a texture and in real time, this texture is saved inside the random X memory or the normal like system memory. And in order to apply this to an object that is already exists in world, like for maybe a character that we have some details on the face, and I need to change these details. For example, like if I want to make a makeup for a character, or I want like a bullet hit to the face that I want this effect to happen. I need to grab like some texture from the system memory and then move that to the GPU memory, then apply it to the material. And this process is just like a huge overhead, and it's really heavy. So render target is something that you can do this in like real time, and you can always do this like they recommend on Unreal Engine website. You cannot just change the main texture. So the workaround for that is you can lerb the alpha channel between two textures. Like texture will be the render target, and the main texture will be the actual main texture. Then you lerb it with the effect that you want to make, as we're going to see in the example right now. So that's a huge benefit and a huge performance boost to use just directly the video memory, and it's getting saved inside the high bitrate memory, which is a video memory. So yeah, we can define it. That is not a strict definition for render targets, but let's call it like what are render targets inside Unreal Engine. So they are basically a thing that you can draw in, and then you can save it after that as a texture. And the nice thing about that, it's just getting saved into the GPU or the VRAM. So that's it. It's much better performance wise. Yeah, there are some examples for like on how you maybe can use them. Of course, like a lot of the things that I'm going to mention here is something that you can work around with materials and playing around with its parameters, but mostly comes back to the fact that you can change the render target and maybe save it to a texture. You can just apply the render target to and lerb it with a material that exists, and you can also save a thing or a capture that you take from the world and save this to a texture and then come back to it later. So yeah, those are the examples from the Unreal Engine documentation. So like you can do a height map painter, a fluid surface simulation, runtime paint program. Like you can draw on the screen. Like that's basically the whole point of having a render target as a concept in the first place. So yeah, deforming surfaces, like when you have something that's crashing and like ground that has something that smashed it, you have this symbol bumps. You can do it using render targets. So yeah, and here I grabbed some of the examples. One of this, like a good thing to use here. This is the example of doing a like a height map enter, like something that you can. I believe I'm not really sure about this, but I believe this is a way that they use when they do the actual the environment builder tools. But for this specific logic, if you going back and see, like try to think on how this thing is being done, it's just done through a line trace, and this line trace by channel have a very important function, which grabs you the location of the UV map that's inside this object. Then I can specifically change this specific area inside the UV map, and this is how we can implement like how the bullet would hit a specific location, and how for example, like how where is the specific area that we want to draw, or for the fluid simulations thing, how this actual area starts the sine wave of this water floating. So that's a really nice thing that we can use render targets onto. So yeah, and another example is runtime paint program. It's just a most basic thing. It's like you can like a whiteboard that you can draw on. And again, I'm referencing here the things that we did in Little Tricker, which is yeah, the cleaning stuff. You have one of the of the limitation of the thing that you can only access the alpha channel, and that's how we actually used it when doing the cleaning stuff, which was try to put a specific values in this alpha channel when I start drawing on a specific UV map location inside the once I had this this object. So that's how I actually used it. That's a little interesting example of using that too. And again, yeah, like this is how like we use the bullets to hit a specific area, and like just using line trace, getting the UV coordinates for that X and Y, and then inside these coordinate draw a specific material to render target, then apply this render target onto the material. That's like how the workflow goes. Again, like if you want to deform a surface, this is just like painting on a surface. And if you want to deform a surface, what you basically want to do is just like do what's here, which is like use the wallet position offset to apply these deforms and work with that. So yeah, another thing here, which is this is a good title to have. It's something that are going to help you in using them, and kind of like you'll never going to use render targets and runtime without, I think, like one of these three. So if you're using line trace by channel, you'll find a function called find collision UV. Will get you the X and Y coordinates of the UV map. Then you can change it, like you know specifically where to put this to spin, and how to deform the surface, and put this in actual like the wallet position offset bin. So scene capture, the scene capture to the component, it's a thing that's commonly used with render target to show the capture of the scene capture 2D. But yeah, warning about that, it's really heavy, and make sure to know when to use it and how to use it. And if you're going to optimize the actual output that comes from the scene capture, just like pay attention to that when you use it. Pay attention to that when you use it, and there's if you want to make it once you put the scene capture 2D on the level, you want like to ask yourself a question: okay, do I want to capture this every frame or not? Because this is a huge performance problem. if you just use it mindlessly. So it will hurt a lot of the performance. So in materials, you can use a texture parameter and layer it with texture. This is just like a quick example on what you can do it inside the materials themselves. And you can use it with world positioning, offset. You can use it with the alpha channel, and like you can do a bunch of things using this thing. So like the limitations. So the last thing will be the limitations, and it's something that I really have to. We did mention the first one. You cannot draw on the render targets that's being assembled as a texture. You did it like I described before, which is like you use the alpha channel to blend between them. Go first between them, and so when you try to draw material to a render target, the only thing that gets drawn, not the base color, it's just like the emissive color and the opacity channels. So those are the outputs. So you need to use the type of material that will make that will produce your desired color with these specific channels. And lighting is not supported when using render targets. We faced this when working with Little Tracker. So lighting is not supported when using render targets and material expression nodes. Emissive color. Exclamated is just a positive. You need to just pay attention to that. If you need to use like the negative values, just make sure to check this, like allow negative emissive color property. And that's mostly it. So, any questions?
Okay, great job. So I was thinking that probably another example that came to mind in games, because I was trying to think of maybe where I've seen it outside of the examples you gave. Another one was a mini map or a map reveal with a fog of war. So, when you have like in the action RPGs or Horizon Zero Dawn and quite a few games have it, God of War, where you look at your map and there's a fog of war over everything because you haven't explored it yet. And so I assume then that they have a base image of whatever the thing is, and then there's a separate render target. The player's a brush, and so as they run through, that's then blending between, I guess,
render target and the actual.
Right. So the render target's almost like a mask. The player's a brush, and then it's lerping between the render target and the base image, and like basically making the opacity 0 in some area there.
Yeah, that's really interesting.
Which sort of goes back to your drawing example when we were talking about render targets drawing. It's essentially drawing in runtime, but the player's the brush running across the map.
The player here is just literally the brush, like you said, and he's just like changing the opacity mask of this image and blend these two on top of each other in order. I think maybe that's how League of Legends do it. It's it's literally the same because it like the way it looks is just like a faded like circle brush, and that's how exactly that it does.
Oh, but what's interesting in League of Legends? So that's an interesting question because in the examples I was thinking of, when it is drawn, but League of Legends is a bit special in that fog of war is removed as a result of the illumination of something. So you put a ward down and that area is illuminated, but when the ward is gone, it disappears. Same thing with the player. When you walk into an area or you're at a certain height, it will reveal. Do you draw and?
I think if I'm going to approach that, I will do like two different render targets, and inside the map of the maybe red team and the blue team, inside the map of the red team, I will use a render target that has a specific rules, and for the red team it will do the same. But I will show this mask for the consequence, like for each one of them, So I'll make two separate
because
render targets.
it is a shared state, right? Because
Mm.
someone in the bottom lane can see someone in the top lane if they're running through the jungle, and everyone has visibility on each other's location
Yeah,
on the
yeah.
same team. Yep.
That's a really interesting example to think at.
Yeah.
So,
But
yeah,
that was
and
it for me. That was a really good presentation. It made a lot of sense.
Oh yeah, I do have a question.
go ahead.
You mentioned different methods. I don't know if this was mentioned, but which one of them would be the most cost efficient? But maybe it depends on the context, depending on what you want to achieve.
Yeah, so those are not just methods. Those are like let's say tools that you can use with them. I believe you're asking about this specific slide. Yes, it.
For anything, I guess.
Yeah. So
I don't have an example in mind.
yeah, approach for that. Like when I was talking about performance issues, so the approach that people will take for solving the same issues, just like having a texture on the system memory and move this texture from system memory to video memory at runtime, and this process of moving this from here is just so heavy. And this is solved
Yes.
now by having something like render target and save it as a texture at runtime, because render targets get saved
And just to
on
verify,
memory.
when a render target is created, it's a process of creating a texture that we can edit at runtime. We can save multiple render targets, reference them as we
Yeah.
need, recycle them. And so when we take the example of a bullet decal, uh, as I get hit per bullet, right, and the decal happens, is that a single render target that's applied on the character, or are these multiple render targets for the different bullet holes?
The
Uh,
deformation would be an individual render
Render
target,
target. Okay.
and the bullet hits like
it's a pro.
the decal itself is its own
Is its own instance
text.
that gets
Yeah,
applied.
its own. Yeah,
Yeah. Yeah, I think like the way I did it's something close to this, which like you have the render target, you draw a material, and then like have this render target blend with the main texture. So this is how the flow goes.
Right, and I guess to what Tim was saying on the bullet hole is the render target is applied to do the deformation, which kind of goes back to the example you had with the height map, where you have sort of the line trace, right? And so then the deformation gets applied to that area of the mesh, and then the decal is placed on that render target, and the decal naturally sort of I'm just going to use the phrase bottoming out, which I think you guys know what I mean. Is it just sort of glues itself to the
Yeah, yeah.
the surface to match that deformation, whatever it is.
Yeah.
So Sammy, it feels like if you go back to the slide where you had the tools, Ahmed.
The tools.
Yeah. Oh, that one. Yeah.
Mhm.
It feels like really the most common case is a combination between the first bullet and the third bullet. So in what we were
Yeah.
just talking about with the bullet hole, what would happen is the sequence would be that there's a line trace and you find the collision UV, and then you apply the deformation, and then actually no, in that one you just apply decal. No, they're two separate.
Yeah,
Yeah.
you use a line trace, you get the actual coordinate, and once you have the actual UV coordinate, you can do anything.
Yeah.
You can just apply you can draw the thing, and it doesn't have to be a decal. Like if you do the deformation through a like maybe world positioning offset, or maybe a normal, you can, I think you can do that too. So you can just like lerp the value that's going into the word positioning offset with the main texture that you create
Yep.
inside this specific point inside the x and y coordinate of the UV map. Then you can just do the deformation thing that you were talking about.
Yep.
So
Yep. So
it's
then,
more
Yeah.
than a lot
so
of stuff.
question I have. So Sammy, commenting out loud, The first one's the bullet hole one that we were talking about, and then the third one is more the minimap one. Sort of each one in isolation hits those. The second one with the scene capture 2D. So is my understanding correct that it will do an actual scene capture, but you generally don't want to do this on every frame, but when the scene capture is performed, it will do a 2D capture of the current view as a render target so that you can then do things on it?
Yeah, well, the way I understand this, just like I always reference like you have like multiple scene capture, and maybe like deform this somehow to make this greenish color of the CCTV cameras, if you relate to that, and then like display this, like you want a thing to display the output of the scene capture 2D inside. So each frame that you get from the from the scene capture 2D, you can just display on a render target. So that's how you can make like more than one CCTV camera, and blends them together. But again, this is insufficient. This is if this scene capture is going to capture every frame and you put 4 or 5 of them, you basically lost like more than four times your.
But the cost there isn't necessarily to do with the fact that it's a render target. It's the fact that you've now got
Renders
another
at the same
camera.
price.
You've got another camera in the scene,
Yeah.
which needs to do stuff, and it needs to render all the lights, the shadows, etc. Because a lot of the performance improvements, a lot of the reason why you can render millions of things on the screen at once is because it doesn't have to render all the stuff that's outside the part that you're looking at. You've got the view frustum culling thing, and as soon as you add another camera, now you have to calculate. Yeah, you have to calculate the stuff from a completely different angle, and that's why you'll notice that in many games the CCTV stuff will be low resolution.
Yeah.
It's not just because not just like a retro thing. It's a performance thing. Yeah.
Yeah, it's a really expensive thing to implement, and you need to be cautious while using that. So that's
Well,
why.
it's a good point to what Tim's mentioning, right? Because every time you add a camera, now that camera has to run everything it's looking at through the same rendering pipeline that we need to do for the character camera. And if you have 4, it has to do that for every one. And as you're saying, you have to run it through the vertex shader. You have to run it through the pixel shader. You have to do the depth tests.
Everything, yeah.
There. You have to do the culling. And then all of a sudden you have to do it for all the cameras and then lighting, shadows, and the rest. Yeah.
You basically render the scene twice. Like it's you render the just render the scene like twice.
Yeah. So I think it's a great point in that probably the render target itself is not costly, but the use of it for something like a scene capture, if you're adding multiple cameras in, is sort of the root cause of that.
Yes, exactly. That's
a good point.
Yeah.
Cool. Any other questions?
Yes. Do you think it's a thing that can be saved after playing, for example, to use to doodle notes on the level, for example?
So yes, I think you can do that, but you'll have to do this in. I think there's while looking for that, I stumbled across a C++ code that can do that, and an Unreal Engine plugin that can do that too, and save it like at a PNG or save it like a file outside of the project.
Or for example, like do it just in the editor. Just for example, you need to move like one palm tree a bit to the right, and you just do a couple of lines with an arrow inside the editor without having to touch the 3D models and break anything.
Yeah, I think we can do that. I think. Yeah, correct me if I'm wrong, but I think we can do that.
Kind of like the grease pencil layer in Blender.
Yeah, that's possible. So
Yeah.
what you're talking about is like annotating the scene with hand drawn, markers and stuff like that, right? Yeah, that's totally doable. Yeah.
Yeah, I think it's doable.
That will be cool. Instead of, like, for example, taking screenshots of every part and annotating on the screenshots, just annotate directly in the editor.
Yeah.
Especially for games that don't have a fixed perspective, you can go to, for example, inside of a corridor or inside of a window and annotate directly inside the indoor spaces.
Yeah.
Things like that.
Yep.
Yeah.
That's totally doable. Yeah, I think.
All right.
It would
Yeah,
be,
it sounds like you
if it
volunteered
doesn't
yourself for
exist,
something
that
cool.
will be a cool plugin.
Awesome. All right. Anything else?
Yeah, I think that's it.
Great.
Yep. Yeah, thank you.
All right. Okay.